we said that normal distribution is used for continuous data sets. So normal distribution is a symmetrical bell-shaped distribution. This is what we mean by symmetrical and bell-shaped. This is the bell-shaped we're talking about. And where most values cluster around the mean and fewer values occur at the extremes. We're going to get deeply into this in a second. Now, what are the key characteristics of a normal distribution? It's bell-shaped. Firstly, I have showed you what that means. The mean, median, mode are all equal. Take note of that. That's very important. It's symmetrical and most values lie near the center. Why is normal distribution significant? Why does it matter? Because in many biological variables many biological variables follow normal distribution, such as height, weight, blood pressure, pulse rate, right? And these are all continuous data, and many statistical tests assume normality. This image, I think we should take note of it, and there are some things we're going to get back to in a second, but this is the bell shape. Now where you have 0, that's where you have the mean, and remember the mean is equals to the median is equals to the mode. We'll get back here. So what is the rule? What are the rules for normal distribution? Plus or minus 1 standard deviation falls between 6 covers 68%. Plus or minus 2 standard deviation covers 95%. Plus or minus 3 standard deviation covers 99.7%. Take note of this. This is very helpful, but this image will help us understand better. Remember that standard deviation is how far the values are from the mean. So you can see here -1 and 1. So 68% of the data falls between -1 and 1, right? 95% falls between -2 and 2. 99.7 falls between -3 and 3. That is what it means. We're going to use an example here. Now, for example, we have the mean systolic blood pressure to be 120. This is classical, right? 120 is the mean systolic blood pressure. And for those who do not know what systolic blood pressure is, if you have your blood pressure to be 120/80, the one on top is the systolic, right? So, plus or minus 1 standard deviation. Remember, 120 minus 1 gives you 110. 120 plus 10, sorry, gives you 130. That means 68%. Remember the image we had. 68% of the data falls between -1 and 1. So 68% of healthy individuals fall in this range. That's normal. Now the next range is plus or minus 2. 120, 2 times the standard deviation. Remember that the standard deviation was 10. So 2 times 10 is 20. So 2 times, and 120 minus 20 is going to give you 100. 120 plus 20 gives you 140. That means 95% of the people fall between 100 to 140 millimeter mercury. Right? These are common, but here the values near edges may require monitoring. Now in plus or minus 3, remember 3 times 10 is 30. That's how we got the 30. 120 minus 30 gives you 90. 120 plus 30 gives you 150. About 99, remember 99%, remember that for plus or minus 3 it is 99.7% of people that falls in. That means values outside this are very, very unusual, right? Values below 90 is very unusual. Values above 150 is very unusual, and it's likely pathological. That means it's maybe a disease or something, or the measurement is incorrect. Now the next example is when you have the mean hemoglobin level to be 14, and then the standard deviation is 1. 14 minus 1, 13. 14 plus 1, 15. That means the normal range is between 13 and 15. This is how they get those values that you see sometimes when in physiology, right? So the normal value is 13 to 15, and that's the normal one. And remember that 68% falls into this category. Now 2 times 1 is obviously 2, right? 14 minus 2 is 12. 14 plus 2 gives you 16. Remember that 95% falls here. Now 14 minus 3 gives you 11. 14 plus 3 gives you 17. These are the extremes. That means anything below 11 or anything above 17 is significant. It indicates a problem. So it could indicate condition like bradycardia, right? Could indicate a condition. So these are some of the ways that we get the values, the range of values that we have, especially in medical and the nursing sciences, which is one of the importance of normal distribution.